Now, topic third. First thing, factors that should be considered. Factors that should be considered before choosing a type of casting. A type of casting. Number one is part shape and size. Number second is the required quantity. Required quantity. Number third is the material using. The material that is to be used in casting. Used in casting is to be. Number four is the tolerance. So, for example, if you have number of cards that are in 1000, you have to go with a permanent mold casting. If the part shape is complex or intricate, then we can decide whether we will go for an expendable type of casting, or we use a permanent mold casting. Now, material used in casting to be if we are using low tolerances, we need a good surface finish or other things, then we should consider that whether we should go for an expendable or a permanent mold casting. These are the factors that should be considered before choosing a type of casting. Now, what are the advantages of casting? As we have studied casting, advantages of casting. Now, number one advantage of the casting is that molten metal can flow in any small section. Molten metal can flow in any small cross section. Second is any complex or intricate shape can be made both ferrous and non-ferrous materials can be cast. Now, about disadvantages, that is poor surface finish, dimensional inaccuracy, and defects arising out of moisture present in casting. So these were some advantages, disadvantages, and the factors that should be considered before selecting a casting process. Now, before proceeding further, let's be familiar with the terms that are associated with casting. Main terms that are associated with casting. Now, let's start with the terminologies, that's terms associated with the casting. Our first term, that is, we called it as a flask. Our first term, that's a flask. This is a flask. A molding flask is one which holds the sand mold intact. It holds the sand mold intact. First thing is, flask holds the sand mold intact. Secondly, it shapes the outer boundary of the sand. Now, Depending upon the position of the flask, depending upon the position of the flask in the mold structure, it is referred by various names such as drag, cope, cheap. It is made up of wood for temporary application or more generally of metal or a long term use. Temporarily, it is it is made of wood, or for long use it is made of steel. Mostly it has a rectangular shape. This is a top view with thinner thickness, and this is the front view of the flask. This flask has an clip arrangement to match the flask and to match the flask and to align the flask. Now the upper part of the flask, it is called cope. It is used for making the upper part of the casting, and the lower part it is called as drag. If between cope and the drag there is another flask that is between cope and drag, then this is called as cheek. If we have a third part that is between cope and the drag, then this part is called as it is called as cheek. Okay. Now this was all about flask. Now you can see from the diagram that we have a part here and we have a part here. This is called a core. It is used for making hollow cavities in the cast. It is used for making hollow cavities in the cast. As you can see that when this casting will be filled with molten material, we can see that the casting will take all the open spaces except the one that is adapted, except the one that is held by a core. That is why this creates a hollow cavity in the casting. So this was all about core, that it is used for making a hollow casting or hollow cavities in the casting. The third one is a pouring cup or a pouring basin. Pouring cup, or a pouring basin. It is small funnel shaped cavity at the top of the mold into which the molten metal is poured. In the diagram, you can see this pouring basin, and this is a pouring cup from which the molten material starts entering into the mold. After pouring basin, we have another part that is called as sprue or down sprue. It is here written as down sprue. It is a passage through which the molten material. It is a passage through which the molten material from the pouring basin reaches the mold cavity. In many cases, it controls the flow of metal into the mold. Another part that is called as a runner. This is a runner. The passage way, this is the passage way in the parting plane through which the molten metal flow is regulated before they reach the mold cavity. Now, this part is called as parting line. Parting line divides the flask into two parts, and it also divides this pattern or this mold cavity into two parts. This is divided into two parts, the upper part and the lower part. It is called as parting line. This is through the parting line that this passage makes a way for molten material to enter the mold cavity. Now another point here, it is called as gate. Gate. It is an actual entry point through which molten material or molten metal enters the mold cavity. So gate is an actual entry point to the mold cavity. Now in the upper diagram you can see a chaplet, something that holds the core. So it's called as chaplet. Now chaplets are used to support cores. These are used to support cores inside the mold cavity to take care of their own weight and overcome the metallostatic forces. These metallostatic forces that are created by the molten material. So it is used to hold the core at its right position. Another term that is being used with this casting is chills. Chills. What is chills are basically a metallic objects. These are metallic objects which are placed in the mold to increase the cooling rate, to increase the cooling rate of castings, to provide uniform or desired cooling rate or desired cooling rate. So the main aim of the riser is to compensate the shrinkage allowances and to know whether the casting has been completely filled or not. The risers are divided into various types like open risers, side risers, top risers. Depending upon the function they have to do while casting. Now another very important term related to casting is a pattern. Basically, pattern is a replica of final object to be made. Object to be made. Simply, I can say that if, for example, I have to make a final casting like this, then first I will make a replica of this that is made up of wood or aluminium, or aluminium, wood or aluminium, and will place it in a flask. Then will rand the sand around it till this sand gets a cavity that is of the same shape of the pattern. Then we will remove the pattern and the sand will get the same shape as that of a pattern. This pattern can be used many times to create cavities in a mold box or in a molding material. So this is the pattern. So pattern can be defined as the replica of final object to be made. Moreover, we can also see from this figure that now we know about cope, that's upper part of the flask, drag, that's the lower part of the flask, that's a mold material, it can be a sand. We know about the runners, rising, gating design, pouring basin, parting line, vent. Yes, vent, it is used to make the gases pass away or pass out of the casting. These are created by vent wires so that gases will escape out of these vents, and casting will be defect free. Now, moreover, we can also see from these diagrams that here we have an open mold and a closed mold. It is an open mold, that is it is directly exposed to environment. That is when we shape a liquid in it is in the open mold, it is exposed to atmosphere and it's called open mold. While it is a closed mold, here uh, this here the casting is not directly, or here mold is not directly exposed to the environment. Open mold, it is like an open container in the desired shape, which must be flat at the top or at the bottom. We cannot. That means it. This type of mold has good surface finish only on the one side, while in the closed mold we can have good surface finish on both of the sides. Open mold, here we can see that it's a single sided mold. There is no parting line, it cannot be divided into two parts. While as in a closed mold, it is a double side mold, that is, it has one part above on the upper side, that is the cope side, and it has one part in the drag side, that is the lower part side. So cavity, in closed mold cavity, there is entirely this is entirely enclosed by the mold with a passageway called the gating system. This is the passageway from sprue to runner to gate, and there is a riser system, and then to the cavity. So there is a complete passageway, or that is called the gating system, leading from the outside. So here we can also see the difference between a closed mold and an open mold. In next lectures, we will start with the types of patterns and types of pattern allowances, and also we will start about the different types of sands and the main requirements for a molding material.